friends, Miss C here. We're going to talk about 1-7 today, which is going to go on page 12 of your notebook. Our learning objective is to write and solve absolute value equations and inequalities using inverse operations. Our language acquisition objective is to explain how to write and solve, again, absolute value equations and inequalities using academic vocabulary. And our essential question is, why does the solution for an absolute value equation or inequality typically result in a pair meaning two equations or inequalities? All right. So, example 1, understand absolute value equations. Note that absolute value represents the distance from 0 on a number line. So when you talk about absolute value, most of the times people say that absolute value just means always positive. That's true, but it's only true because distance can't be negative. That's why answers to absolute value questions are often positive, because we're talking about distance. But the misconception is when we are talking about absolute value, we are just talking about things being the same distance away from 0 on a number line. So, for example, if I'm looking at A, which is the absolute value of x equals 10, we want to know where we're going to be when we're at 0 if we go 10 spaces. So if I go 10 spaces to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I am at 10. So x equals 10. Now, is that the only answer? No, because there's a whole nother side. There's a whole left side, which is also 10 spaces away. So if I go 10 spaces to the left, where do I end up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I end up at x equals -10. So there are two answers. They want to know where are you if you go 10 spaces to the right and 10 spaces to the left. And that right there, my friends, is the answer to absolute value. That's why there's two solutions, because there's a right side of the number line and a left side of the number line. Let's do one more together. Actually, two more together. How about that? B, absolute value of 5. So if I go to the right, when I start at 0, I go to the right, 1, 2, 3, 4, 5, I'm at 5. So x equals 5. Sorry guys, I messed that up. 5. Now if I go to the left, five, 1, 2, 3, 4, 5, I'm at x equals -5. Notice that they're the same number, they are just one's positive and one's negative. Okay, now we're at C. Where is something -3 away from 0? Most of you guys are going to say that this is -3, but we just discussed that distance can't be negative. And this is talking about distance. So this 5 was positive, but when we went 5 spaces right and 5 spaces left, we got a +5 and a -5 as our answers. But when we talk about our answer here being -3, our distance is negative, and that's not a thing that can happen. We can't go -3 on a number line. We either go 3 spaces right or 3 spaces left. Those are the only options. So, since distance can't be negative, we call this a no solution. That's our answer, because distance can't be negative. All right, one last one I'm going to do with you is D, letter D. So I've got 7 equals our absolute value of x plus 2. Whenever you see absolute value around x, we need to first use inverse operations to get the absolute value by itself so that it's on one side, just like it was in A and B and in C. See how absolute value had nothing around it? So I'm going to move this positive 2 by doing exactly what we've been doing for the past month. By using inverse operations, I'm going to subtract it on either side. 7 minus 2 is 5 equals the absolute value of x. And then, where am I going to be? 5 spaces right. If I go back to B, I know that if I go 5 spaces right, I get x equals 5. And if I go 5 spaces to the left, I get x equals negative 5. Those are my answers. What I want you to do is you try E. All right? Pause, and I will see you for number 2 of example 1. Okay, now that you should have tried E, we're going to now move on to solving absolute value equations of the form ax plus b in absolute value bars equals c. Here are our steps for solving absolute value equations. Our first step is to isolate the absolute value on one side if necessary. When I'm talking about isolating, I'm talking about problems like D, where we had to move the 2 over to get the absolute value bars by itself. Step 2 would be to remove the expression from the absolute value and then write 2 equations, one with a positive and one with a negative answer. Then 3, you solve both equations, and you guessed it, using inverse operations. My spelling is terrible. Now, here's something new. You are never, ever, 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 ever distributing across absolute value bars. They are not parentheses. They are not parentheses. They are not parentheses. So do not distribute over them, okay? All right, let's get started. So A, I see 2x minus 3 inside the absolute value bars equals 1. Our first step is to isolate the absolute value on one side if necessary. There is nothing on the outside of the absolute value bar, so it's already isolated. Excuse me. Number 2, remove the expression from the absolute value bar and write 2 equations, one with positive and one with a negative answer. So I tried to make this as easy as possible. So we're going to remove the absolute value bars and write the expression 2x minus 3 equals, and our first solution is going to be positive. So this is positive 1, because we're talking about our first step of the number line, one space to the number right on the number line. So then our second solution is going to be the negative version of that. So we're going to have 2x minus 3 equals negative 1, because it could also be negative 1 space on the number line. So now we need to know what x equals. So we solve these 2 different ways. We're going to add 3. So I get 2x equals 4, because those 3's cancel. Divide by 2, and I get x equals 2 as my first answer. And we know the absolute value always has 2. Now on the other side, I'm going to add 3. I get 2x equals 2. Divide by 2, and I get x equals 1. This means that if I were to plug in 2 in for x, and let's see, if I just do it, I get 2 times 2, which is 4, minus 3, and I get 1. The absolute value of 1 is 1 unit away from 0. That is true. If I plugged in positive 1 in for x, 2 times 1 is 2, minus 3 is negative 1, and the absolute value of negative 1 is also 1 space away from 0. So our answers check out. And that's all we got to do. Okay, B. I just realized I wrote the same questions. So I'm going to change this. I'm going to say 2x, stop moving, 2x minus 5. Let's change that to a 5. And then let's see, let's make this a 7. How about that? Okay, let's try it out. So our first step is to write it with the positive. 2x minus 5 equals 7. And our second solution is going to be with the negative. 2x minus 5 equals negative 7. Okay, our first step would be to add 5, and I get 2x equals 12. Then I divide by 2, and I get x equals 6. That's my first one. My second solution, I'm going to add 5, 2x equals negative 2, divide by 2, and I get x equals negative 1. So if I plug these numbers in for x here, I'm going to get two numbers that are equidistant from each other on the number line. They will both be 7 units away from 0. All right, let's go to the back side. All right, the last problem I'm going to do with you is C, letter C. And here's where we need to isolate. So we need to actually move things around. And we move things around the same way that it would be if we saw 3x plus 8 equals 5. The first step would be to, in fact, move the 8 by subtracting it. But instead, we've got absolute value bars around this x. So I'm going to move 8 here, just like I would in this problem. And I get 3 absolute value bar x plus 6 and absolute value bar equals, and then 5 minus 8 is negative 3. Then I'm going to, just like I had 3x equals negative 3, I would divide here, but again, absolute value bars protect that x. So I'm going to divide by 3 on either side here. So my new equation with absolute value bars is absolute value of x plus 6 equals negative 1. Okay, now that I have isolated and I know what my problem is, now I can split it up into two separate solutions. So I'll have the absolute value of x plus, or actually not even absolute value anymore. I will instead have x plus 6 equals negative 1. Positive just means the same, so keep it the same. And then the opposite. So x plus 6 equals positive 1. And now I'm going to subtract 6 on the left. And I get x equals negative 7 as my first answer. And on the right, subtract 6, and x equals negative 5 as my second answer. Okay, D is a try it, and then E is a U, and then you are going to write a question or connection for this video. I'm going to go ahead and leave you with the answers to D, and you need to try it. We know what happens with Miss E when she thinks that you don't try it. You need to try it. It'll go faster in class if you come with something done. All right, so I'm going to pause. I'm going to give you guys the answers to D, not the work, just the answers, and then you need to do this chunk summary down here. Okay, I'm back. So I got x equals negative 3 for the first solution and x equals negative 7 as our second solution. Try your best to get there. If you don't, you don't. Be a good student so I can be a good teacher. I will see you later. Bye!